Thanks for coming to our talk. It's great to be here at Q2B. So today we'll be telling you about our latest thinking on how we can create a comprehensive set of capabilities for our customers from not only research, but also the sort of continuous process from research to production. So I'm Yudong, and I'm CTO, and joining me today will be Amara, who leads our hardware efforts. Well, not hardware efforts, a team focusing on software-facing quantum hardware. So to start off with a bit of a co-founder perspective, so Zapata's mission is to deliver first-mover quantum advantage to enterprise customers, and much is to be sort of unpacked about what quantum advantage means. So the first part of the statement is that we want to provide the tools and means to enable extensive research to gauge the level of quantum advantage in practice and to get more performance out of quantum hardware. So Amara will talk about one specific example of how we do that with Orchestra. And then the second part, which is the part I want to spend a bit more time telling you about, is how Orchestra and Zapata scientists support the journey of a quantum-ready application. So it's the journey from research in the cloud, also in the local workstation, to deployment in the customer's enterprise environment. So this is a schematics of what the journey looks like. Typically, where we start is what we call use case discovery. So we will engage with our team, will engage with the customer in a typically 6 to 9 months period of time, where we identify the stakeholders and technical specialists and really surface the use cases that has the potential for uncovering quantum advantage in a reasonable period of time, or to develop quantum-ready applications where we set the stage for quantum computers to be integrated into the application and solve the problem. And the journey of this application development is sort of divided into the pilot phase, where we start identifying we start building a proof of value prototype and identify the core issues related to making the application work, and then have the initial phase and have an initial phase of operationalization or deployment. And then the process between pilot development and deployment is very much iterative. So in the case of machine learning or ML ops, we very much want, for example, our model developed in the research environment to be deployed in the operational environment. And then to update the model, we want to be able to effectively update the model in the research environment using the data from production. So we're very much seeing this sort of iterative relationship between pilots and deployed application. So all of this process is enabled by Orchestra as a vehicle that drives the whole journey from use case discovery to quantum-ready application. And also alongside this journey, alongside the software tools and infrastructure, we also provide customers with access to our own Zapata expertise. So we have more than 30 world-class quantum algorithm experts in different domain areas in machine learning, optimization, chemistry, simulation, etc. So hopefully that gives you a picture of sort of what our enterprise solution looks like. In other words, we're presenting to a customer not just the software tools, but also a bundle. So you get the platform, you get the specific Zapata IP-supported libraries and algorithms, but also eventually what we call quantum-ready applications. And in many cases, the very effort to set the stage to build these quantum-ready applications can already generate tangible business values. So if you come to our booth, and then we'll be able to talk you through more about the specific examples of what a customer engagement looks like. So 2 years ago, we released Orchestra for the first time, and we've undergone some significant iterations in the past 2 years, incorporating feedback from customers and users. So for some of you, this may not be new. This is the overall framework of how we think about building and deploying quantum-ready applications, where it starts from creating these computational workflows that leverage a collection of existing libraries. So these are libraries for building quantum programs, and also some of the libraries that are more domain-specific, and other methods that are sort of more on the software infrastructure side. So we have a means to create these orchestral workflows locally, and execute these workflows both locally on the workstation and also scale that up to cloud, and both private and public cloud. So this is the sort of create phase. And then once the workflow is executed, there are additional features that Orquestra provides in terms of monitoring and ensuring that we not only have stable access to the hardware, but also we're teasing out the most performance from the hardware. And then there's also sort of flexibility in the sort of database endpoint that you can connect to these workflows. So you can run a large experiment testing, say, 10 different quantum algorithms on 5 different quantum hardware, and then you probably have a place to store all that data. And there's a sort of database endpoint that you can use to visualize and post-process the data. So some of the commonly used ones are Tableau and Excel, but there are also other database endpoints that you can support. So at a high level, we're not only enabling sort of the typical hardware agnostic feature, but also we want to enable agnosticity across the stack. So we want to be able to integrate all the major hardware and software components, plus additional access to Zapata team and IP embodied in the libraries and suites that you can get on top of Orchestra. And then the platform is built with enterprise scale and security in mind, because we want to think about all the way from research to production. And it can be run on both Zapata hosted cloud or customer cloud. So last night we had a private showing of Orchestra Studio, but if you're interested, you can also come to our booth to see more. So this is very much the result of our evolution in the past 2 years. The first version of Orchestra supports the syntax of building the workflow, which is perhaps more familiar to the cloud engineers rather than the quantum scientists. And we have since iterated the new Orchestra Studio GUI, where the user can now write in the familiar Python syntax to develop a workflow with specific tasks and different artifacts. And so the new GUI supports a more familiar, more intuitive interface. So if you haven't seen it, come to our booth and we'll give you a demo. So next, I will hand over to Amara, who will talk through an example of how Orchestra enhanced the NISQ device performance.
Okay. All right. So thank you. So I'm going to give you an example of how Zapata gives access to our customers to advanced software tools dealing with near-term hardware devices. So during the search for quantum advantage, Zapata offers a number of proprietary algorithms and also access to open source tools in the quantum ecosystem. And for these few slides, I'm going to concentrate on our integration of FireOpal, which is Q-Control's proprietary algorithm, which automates the compilation process and automates pulse optimization. And from Zapata's side, we'll use something called robust amplitude estimation, which is a part of proprietary algorithm to estimate Pauli operators. So what we do is we start with what we call a quantum-enabled workflow. A quantum-enabled workflow has a series of steps or tasks. And the focus of these steps or tasks is really modularity and swappability. So we start with, for this experiment, with an ansatz from Zapata's library of proprietary and open source ansatzes. And all you need to specify the parameters to specify that ansatz in your workflow. Then there are next few steps or tasks to calculate the circuits to run this robust amplitude estimation. And for the quantum simulators, I would like to emphasize that we go beyond simply integration. Like I said, we are focusing on modularity and swappability, so that changing different simulators for us just means changing a couple lines of code. One does not need to worry about the intricacies and idiosyncrasies of each integration for each backend for the user. That's all taken care of by our quantum science software team. And at the firmware level, we're going to be using Q control, Fire Opal. So for this, we have a simulation of a superconducting device. So it has been benchmarked with real quantum devices. And what we see in the top plot is the bias. So 0 will mean that our estimate of Pauli operator was exact. And just to give an idea, the 0 layer is just VQE, standard sampling. And each layer for our ansatz adds about 40 C0 gates, so that the second layer has a total of about 100 C0 gates in a noisy environment. And as you can see, as you increase the layers, the bias increases, as you'd expect from noise. But with Q control, we're able to get the bias down by almost a factor 11. And from the algorithm, what we expect is it was sort of invented to go beyond VQE, because we are pretty sure that VQE it will not be the path to quantum advantage. And the problem there was the sampling efficiency of standard sampling. And what you see here is that as we increase the number of layers, instead the standard deviation of our estimate improves irrespective of the fact that there is noise. And what Q control helps us to do is to reduce the standard deviation by almost a factor of 6. So this is just an example of how, using Orquestra, one has a huge tool of to do science experiments coming from chemistry, machine learning, incorporate many different simulators in a very easy manner, and have access to advanced tools to make near-term quantum computing possible.
Okay, thanks, Amara. So this is one concrete example of how not only Zapata working with the Orchestra, but also incorporating a third-party tool we can improve the performance of algorithms on different hardwares. So just to shift gears, I want to talk about how we collaborate with enterprises to build a quantum-ready application on Orchestra. So I want to start with one specific example, which is what our own innovation coming from the quantum AI team, which is what we call quantum enhanced optimizer. So this is a technique that we have invented for using near-term quantum computers, but as well as quantum-inspired backends to drive concrete improvements for optimization for real-world industry-scale optimization problem. So in this specific paper, you can review the results. In this specific paper, we benchmark the technique on the portfolio optimization, and I won't go into what exactly is a quantum enhancement, but there is a difference in performance between our solution and the benchmark classical solution. So this overall framework, the appeal of this framework is that it is generic to pretty much any optimization problem, black box optimization problem, where the goal is to fine-tune a certain parameter of a customer process or system to yield an output. And in some cases, there's a closed loop feedback. In some cases, the customer system is completely open loop. So we do not require any advanced mathematical formulation of optimization problem, but rather just expects that there's a black box where there's a candidate solution and it evaluates the candidate solution and yields an output. And we have a machine learning approach that uses a near-term quantum computer as a backend. So we actually did a demonstration on an 8-qubit trapped ion last year, where we used a quantum computer to generate handwritten digits. So this is very much a technique that uses existing quantum or quantum-inspired techniques and use that to solve industry-scale optimization problem. So this is, I think, a good example of one of those sort of backbones of a quantum-ready application. It leverages today's small quantum devices and also classical data structure for a general optimization problem. So let's say we have a blueprint of this quantum-ready application we want to build for a customer. What does the customer journey look like? So I'm going to break that down into 5 different pieces. So the first step is that Zapata team will work with the customer to develop the orchestral workflow, which you can think about as a sequence of tasks. So every one of those, so this is a sort of toy workflow. Each one of those is a task inside which could be a container that runs classical or quantum program. And we'll work with you to develop an orchestral workflow. For example, here, this is a workflow that benchmarks a QEO on multiple backends. But in reality, the workflow is a lot more convoluted. And then Orchestra Studio essentially is the UI that stores and develops and monitors the workflow. So this is an interface where developers can see what are the underlying source code and also the data inside a task, and what are the tasks inside a workflow, and then what is the library of tasks. So you can inspect task inputs and outputs and jump into the code, or access just a generic library of existing tasks. So those are sort of the Lego pieces of a workflow. So we've built this workflow, and now we need to run it. And so for us, we support public and private cloud runtimes, and so you can run it on our hosted cloud, and also a variety of public clouds. So there's supposed to be a collection of logos of Google and Amazon and Azure, etc. So we support a variety of public and also a private cloud. And then once the workflow is launched and submitted, there's a dashboard in Studio that allows you to keep track of the progress. Some of those are maybe running, some of those may have already succeeded. And then you can inquire the specific content of each task. So in this case, it's a QEO for portfolio optimization. So maybe there are 4 parallel instances for portfolio optimization, each with different parameters that you like to try. And there's a dashboard to really monitor the state of the workflow. Has it finished yet? If it failed, what is the error log, etc. And then once the workflow has finished, Orchestra bundles the workflow results in Python objects, and then you can cache it and reload it. So this is an example where we use a Python notebook to post-process the data, but you can very well imagine ingesting the output data file for example, into a database or into a more advanced data processing endpoint like Tableau or other tools. So this sort of completes the whole process of how we start from a conceptual outline of a quantum-ready application and end with concrete results. So I want to talk a little bit about what does this application look like to an end user. So you can imagine an organization where you have data scientists who are very savvy with the machine learning models, and then you have maybe DevOps engineer who are very savvy with the deployment environment. And then typically you have a sort of manager persona, a stakeholder persona, who's not so concerned about the technical details of the development and deployment, but just wants a dashboard like this. So in the case of portfolio optimization, this is a dashboard that we build on top of the workflow. So this is obviously a fictional example, but you can see that the very data objects that are generated from the orchestral workflow that I just showed you in the previous slides can be surfaced as entries on these UI for a domain end user. So this is sort of in some way the surface of a quantum-ready application to an end user who is not so concerned about the underlying computational details of a quantum workflow, but rather the output. And the next question is, what might a solution look like in practice for an enterprise seeking quantum advantage? So when we talk about quantum advantage, I think there's a lot of sort of computer science around the algorithmic speed up itself. But in practice, what we learned is that there are infrastructure and also essentially deployment obstacles that will potentially overwhelm whatever algorithmic speed up or algorithmic advantage that one may glean from quantum computing. So this is really what we learned coming from working with enterprise customers, working with their internal environment, and we realized that in many cases, before we can even begin talking about algorithmic advantage, before we can even begin talk about improving this specific slice of the whole stack that runs an algorithm, we need to clean up the data infrastructure. We need to improve the efficiency of the data warehousing. So and then we need to make sure that there's a sort of seamless integration between the production and development and deployment environments. So a big part of the answer is what we call quantum ops. So this includes the typical DevOps that one is concerned with, and also on top of that, the kind of operationalization that's specific to machine learning. So in many cases, you may build a machine learning model in the research workflow, and then train it and deploy it in the application. But this is definitely not so. In the first iteration, you may realize that in production you require some kind of iteration and update. So this is the role of part of quantum ops is definitely to make sure that we have the seamless integration between these two sides. And that's the vision of the Orchestra platform, which is to make sure that we have a consistent vehicle that allows us to go back and forth. And then there are, of course, components that are specific to quantum computing, in addition to the DevOps and MLOps, where we want to make sure that the quantum hardware that we're accessing is performing indeed as what we're expecting that they're performing. So there's a fair amount of device diagnostics, among other checks that we need to make sure, among other monitoring features. So this is sort of a schematic of the enterprise internal environment. This is really to paint a picture of why we are really in this sort of DevOps headspace. So in many cases, the data comes in through a variety of sources. It could be data streams, or it could be in the data lake, or in a sort of heterogeneous set of sources. And then the compute resources that a typical enterprise has internally is also quite varied. So there are typical internal clusters, and then the output is typically towards an even higher level, so enterprise level workflow. And then you throw a quantum computer in the mix, and this is essentially the sort of whole set of challenges that we have to deal with, the set of complexities that we have to deal with when it comes to deploying a full quantum solution into an enterprise architecture. And the object that ties them together is the computational workflow, and that's the vision of Orchestra, which is to develop and deploy a computational workflow that ties these resources together, or at least can work seamlessly with these resources together. And of course, the scenario becomes more complicated when we are looking at hybrid multi-cloud infrastructure possibilities. Today's quantum computers are mostly accessed through cloud endpoints. So this is also a factor that adds to the complexity, and the production solution should be distributed across multiple physical and virtual infrastructures. And there are many more dimensions to the deployment, which I certainly won't have the time to enumerate, but you can see each one of those can be industry specific. In finance industry, there's a specific set of regulatory compliances that is different from, say, pharmaceutical industry, and then the level of data security required, and the governance and operations. So these are all the sort of additional dimensions that comes into play when we move from the sort of R&D scenario into a deployment. And this is sort of to reiterate the previous point that a lot of the challenge is overlapping with the ML ops. So we're not exactly starting from scratch, but our vision of quantum for enterprise definitely contains the challenge for operationalizing machine learning, and on top of that, operationalizing quantum capabilities. So quantum only serves to intensify many of the challenges classical machine learning already faces. And so I want to leave you with the sort of final summary of what's the sort of value proposition that we provide with Orchestra. I think we're missing a picture here, but this is the sort of the end user application, the GUI that serves only the domain end users who are not concerned about the computational details. And then this is the Orchestra Studio, which enables researchers to build workflows and scale that up on a local workstation and also on the cloud. And then there's the enterprise deployment, where we really deal with the internal complexities of an enterprise environment, and we configure, monitor, and optimize the Orchestra workflow through quantum ops. So this is sort of the big picture of the main value propositions that we're offering. And I don't know if we have time for questions, but if anybody has any, do we have time for questions, or is this not part of this?
Maybe one question.
Okay. Yeah, is there any questions?
Sure.
Right.
Yes, so, and this is a question that hopefully answers the other questions that can't be asked. So, solution developer, working in enterprise, what's the, not VC pitch, but elevator pitch to convince me that this is a tool I want to use for doing these types of cutting edge solutions for my customers?
Right, so, quantum is hard. Getting quantum to work is even harder. So quantum is hard in the sense that there's the science itself is hard. And then getting that to work with existing classical algorithms, that's an additional challenge. And then getting that to work in an internal enterprise IT environment, that's a third layer of challenge. We deal with all of that, with people, with software. So that's I think the shortest pitch.
Dean, we hit our floor. No, very good, thank you.
All right, thank you.
Maybe we can do one more question.
Yeah, all right.
So on a similar note, how easy is it for somebody just to go ahead and get started? I'm a new user and I just want to download this and play around.
Right, so this has to do with the different kind of persona. So if you're a developer, then Studio is the entry point where we will help you. We'll have workshops and tutorials to help you develop quantum workflows, and so for a developer, this is where to get started. If you're a decision maker, if you're, say, a manager of a small quantum group in a company, then I think the use case discovery is the right starting point, where we have workshops and we'll initiate conversations with you and your individual contributors on your team to surface use cases where we can make decision on what's the best strategy forward. And if you're a C-level executive, then there's this additional sort of strategic component into the conversation where you'll be able to meet with some of the more senior leaders of our company to really strategize and map out a long-term plan for quantum transformation in your company. So I think for different levels of users, I think we have different game plan.
Great, thank you.
All right.
Thank the speakers again.
All right. Thank you.